Hello everyone. Welcome back to the sessions on the advanced communication that is for the 5th semester electronics and communication diploma students. In this particular session, we are going to study about the basic pulsed radar. As already we have studied, in the radar there are mainly two types here, pulsed radar and the continuous wave radar here. Pulsed radar and the continuous wave radar in the earlier classes. What is the pulsed radar? That is, if the station is radiating the signal in the form of pulses, then that particular situation is called as the pulsed radar system here. If the radar is radiating the continuous wave signals, then that is called as the continuous wave radar. If you observe here, suppose this animation, this is the radar station here and this is the target here. The radar station is radiating the frequencies, the RF frequencies, and it is receiving the echo signals back here. It is receiving the echo signals back. If these radiated signals are in the form of pulses, then that is called as the pulsed radar system. Using the echo signal, we can get a number of information, that is the whether the target is present or not, and location of the target, and whether it is moving or not, and also it is what is the relative velocity. Like this, different parameters can be calculated there using the echo signal. Now the first one is the pulsed radar here, basic pulsed radar system. This is the block diagram for the basic pulsed radar system. If you observe here in the block diagram, it is divided into, that is, this is the transmitter section here. This is the transmitter section here, and here you will be having the angle data from the antenna. From the antenna we are taking the signal and that is given to the receiver section. This whole thing is the receiver section here, the dotted lines here. This dotted line, inside this dotted line represents the receiver section here. This is the transmitter section and this is the antenna section here. This duplexer and this antenna, this is the antenna section, and this is the trigger source here. Therefore, whole thing we can divide into transmitter section, receiver section, antenna section, and this particular trigger source here. This is the trigger source. Now the explanation starting from the transmitter. As the name only indicate, it is the pulsed radar here. It is the pulsed radar. Therefore, we have to transmit the signal in the form of the pulses here. Now in the transmitter section, we are having the magnetron, which will generate the microwave frequencies here, which is generating the very high frequency signals. Now the signals which are generated, we need to transmit in the form of pulses there. Therefore, this pulse modulator is there. The main purpose of the pulse modulator or main job of the pulse modulator is to turn on and off the magnetron such that the signals generated are transmitted in the form of pulses. That is, whenever it is on, the pulse is transmitted, and whenever it is off, it is blocked here. Therefore, the signal is blocked. Therefore, whatever the signal is generated there, that is transmitted in the form of the pulses. Here, the magnetron is generating the signals here, microwave signals, that is the high frequency signals, and the purpose of the pulse modulator is to make the magnetron tube here on and off such that the signals radiated will be in the form of the pulses there. Now if you observe the trigger source, it is also giving the generating the some square waves here or the trigger signals here. Those are connected to the pulse modulator here. What is the purpose of the trigger source? That is, main purpose of the trigger source is to synchronize the transmitter and the receiver section here. For the synchronization purpose of the transmitter and the receiver, as well as to control the pulse generating processes there through the modulator. To control that also, we need some controlling circuit that is done by this trigger source. Now whenever this is a pulse modulator, it is making this as on, the signal is given here, and through this duplexer it is entering into the antenna here, and that is radiated towards the target. If you observe here, the signals are radiated towards the target here. Now what is the purpose of the duplexer? What is the purpose of the duplexer? In the earlier classes we have studied, the main purpose of the duplexer is for the protection of the receiver section. Because if you observe here, what is happening? The antenna is, single antenna is connected to both transmitter section as well as the receiver section here. The single antenna is connected to both the transmitter as well as the receiver section. Therefore, to protect the very sensitive receiver from the high voltages of the transmitter, because transmitter is radiating the very high power signals there, because it has to travel to the very large long ranges here. Therefore, it is transmitting the high power signals. If by mistake also that enters into the receiver section, that means what will happen? That may damage the sensitive receiver circuits there. Therefore, to avoid that one, we are having the duplexer. It will take care that during the transmission process, temporarily the receiver is disconnected here and the transmission process will be done. And during the receiving process, it is disconnected and all the signals are diverted towards the receiver section there. Therefore, the main purpose of the duplexer is for the protection purpose here. Now that signal is given to the antenna and that is radiated. Once it is radiated, what is happening here? You can see here, the signals are radiated towards the target and echo signals are coming back here towards the station. Once the echo signals are coming back, those are captured by the receiving antenna. Now this antenna will take those signals here, and that is again once again through the duplexer they are entering towards the receiver section here. They are entering towards the receiver section. In the receiver section, the first stage is the low noise RF amplifier. Low noise RF amplifier. The purpose of this is to, because the echo signals received are of very less strength or the low strength here. First, to do the processing, they need some amplification here. Therefore, first stage of amplification is done using the low noise RF amplifier. Along with the amplification, it is also doing the filtering process here. It is removing the unwanted noise signals from the signal which it has received here. Therefore, it is doing the filtering also and it is giving some amplification to the signal here. Now, once the amplification is done here, that signal is applied to the mixer here. That is the mixer. Now, this is the super heterodyne type of the receiver section. Super heterodyne type of the receiver means what? It is converting the incoming signal in the form of the IF signal here. Therefore, whatever the echo signal is there, that is applied here to the mixer, and the local oscillator is generating the signal such that the mixer is giving the IF as the output, intermediate frequency. Therefore, whatever the signal it is needed to generate the IF signal, that is provided by this local oscillator block here. Therefore, the RF amplifier's output and the local oscillator output, those are combined in the mixer and that is applied to the particular mixer here. Now, output of the mixer is, here it is the IF signal here, that is given to the IF amplification. The IF amplification will provide one more stage of the amplification here, and that is given to the detector here. The detector or the demodulator here, such that that will provide the output here, and that is given to the video amplifier here. That is given to the video amplifier for the purpose of the display. It is again forwarded towards the display section here. Video amplifier, again one more stage of the amplification is provided here. And also here, if you can see here, for the display, the part of the transmitted signal is, it is also applied here. From the antenna, it is applied here. Again, the purpose here is for the synchronization purpose here. That is to synchronize when the signal is transmitted and when the echo signal is received back. For that synchronization, to make that timing mark here, they are applying that particular signal here. That is from the particular antenna. Now, this is the explanation for the pulsed radar system. Once again, if you just go through the functional blocks in that pulsed radar system, which is the first block, that is the transmitter section here. Transmitter section is the first block. Second block is the receiver section. Third is the trigger source. And fourth is the duplexer and the antennas. These are the main functional blocks of that pulsed radar system. As we explained here, transmitter, receiver, trigger source and the duplexer and the antenna circuit here. Now, what was the transmitter is doing there? That is it is the microwave oscillator such as a magnetron, which is generating the continuous wave or the RF signals here. Now turned the particular modulator. What is the function of the modulator here? It is making that transmitter section on and off such that the signals are transmitted in the form of the pulses. The signals are transmitted in the form of the pulses there. Now the pulses are controlled and synchronized by the trigger source because we are applying the trigger source also there. Therefore, the main function of the trigger source is to control and also the synchronize the transmitter section and the receiver section. The wave generated at the transmitter is reaching to the particular duplexer and to the antenna, and it is radiated into the space there. Now the receiver section. What is the main block and the functions of the receiver here? Receiver is the super heterodyne type of the receiver. The receiver which is using in the pulsed radar is the super heterodyne type of the receiver here. The first stage is the low noise amplifier section. The first stage is the low noise amplifier section. The RF section amplifies and filters out the unwanted signal. The RF section is the first amplification. It is amplifying as well as it is filtering out the unwanted signal there. And the mixer converts the RF frequency into intermediate frequency that is usually in the range of the 30 to 60 megahertz. In the range of the 30 to 60 megahertz, that particular mixer is converting that incoming RF signal in the form of the IF signal. Now the local oscillator provides the required signal for this particular conversion. Whatever the conversion needed process, the local oscillator is generating that particular signal and it is giving to the mixer here such that mixer will convert the RF into IF signal. IF section provides in the amplification here. That is, IF amplifier is providing the signal amplification to the IF signal here. Next, the detector recovers from the IF signal. That is, detector recovers the information from the IF signal. Whatever the information is present in the IF signal, that is extracted from in the detector circuit, which is taken from the IF signal there. And the detected signal is amplified by the video amplifier to the suitable level such that it can be displayed. And that output is given to the display. And also for the synchronization purpose, the trigger source is also giving some input to that particular display there. The output is displayed on the CRT tape of the monitor there. Now the trigger source. What is the purpose of the trigger source here? Trigger source is used for the producing the pulses of the appropriate time and frequency and synchronizing the transmitter with the receiver here. Means the trigger source is generating the pulses such that those pulses are used for the synchronization purpose and also for the controlling of the transmitter section here. For that purpose, the trigger source is used here. Next is a single parabolic antenna is used for the purpose of the both transmission and the receiving purpose. The angle data is supplied to the display system here. Means at what time the ray is radiated and at what time the signal is coming back. That information is also given to the display system here. Duplexer and the antenna system here. A single antenna is used for both transmitting and the receiving purpose. As we have explained there, the single antenna is used for the both transmission and the receiving purpose. The function of the duplexer is to protect the receiver from the damage caused by the high power radiated by the transmitter, because we have to isolate the receiver section during the transmission time there. Transmitter is transmitting the very high power signals. Now to protect the sensitive receiver, we are using the duplexer circuit there. The duplexer also directs the returned echo signal to the receiver and not to the transmitter. One more job is what? During the receiving time, the duplexer will receive the echo signal. For example, if you observe here, the echo signals are from the target. They are coming towards the radar station. The receiver section will receive that antenna, and those are, instead of transmitter, those are radiated or forwarded towards the receiver section here. That is also one of the job of the duplexer circuit here. This is the simplified explanation for the basic pulsed radar circuit. Thank you one and all for watching. In the next session, we'll go for the next topic there. Thank you.